Okay, in this video we're going to do the remainder of the construction of our robot. What we did in the first video was we essentially built the base, which we built an inanimate object. Our job now is to animate that inanimate object. I have the base. Notice that I've separated the four pairs of wires: front left, front right, back right, and then I also have the stack that we used in the most recent motors lab. I have a pair of battery packs. This is the battery pack that came with the robot. It contains 5 AA batteries. This is another battery pack that should be in your kit. It contains 4 AA batteries. This one has a case and a cover, which is nice. And it also has a power switch, so just make note of where the power switch is. I have this little sled that's going to go on the front of the robot if you want. You don't have to if you don't prefer it. It's been 3D printed, just custom for this project. And then I have the controller, just as we had in the motors lab. And notice that the Bluetooth dongle, which is labeled A in this case, and the PS3 controller are already paired. So all you would need to do is establish the connection once power has been applied. Also notice that, again, this cutout right here will be closer to the front of the robot, so I'll be referring to this end as the front of the robot. You can attach the things. I would recommend attaching them using Velcro. You'll have 3 sets of Velcro in your kit. I've already attached Velcro to the bottom of this controller, so I'm going to go ahead and peel the other Velcro glue off. The white, I would recommend that you put the white toward the back, and the reason for that is you want to be able to gain access to this USB port, and if you put it here, you can go in behind the tire, but if you rotate it this way, there's just simply no way to get through this tire into the USB port. It would actually be a bit more convenient if it could go the other way, but I think that in this case, this is our best choice. Now I'm going to get these wires out of the way here, and I'm going to go ahead and mount it. My recommendation would be to put it right behind that pair of screws. So let me, this is kind of tricky with the tape. If you don't get it perfect, that's okay. Okay, so I've now got this attached, so that's not going anywhere. What you want to do, and well, you can do it any way that you want to do it. I'll tell you how I'm doing it. I took these short pieces of wire, and I've gone ahead and attached them to the screw terminals, and I went ahead and chose M3. That's this one in the front left. I'm using that to control my front left motor. This is going to make it a little bit easy for me to remember which motor is where, so I'm going to go ahead and push these onto here. Now, one thing to notice, and I kind of already figured this out for you, it took a little trial and error. On the left side of the robot, you want the red wires to be on the outside, and on the right side of the robot, you want the white wires or the black wires to be on the outside, the red to be on the inside. That's because, if you remember the way that we put these motors in, they were actually backwards from each other. So this is the way that if I now tell all 4 motors to go, quote, forward, then the robot will go forward. So let's go ahead and attach all 4 of these motors. And it's nice to be able to make these connections so easily. And please don't clip the connectors off. I clipped the connectors off on the first robot that I built, but I really wish that I hadn't, because it was a real hassle to have to undo them and redo them every time. And I undid and redid them about 6 times in the course of developing my robot. So I would encourage you to just put these connectors on like this. Once they've slid on, there's really no opportunity for them to touch each other. You can bend them up a little bit. If you want to bend them all the way over, you can. If you want to tape them down, you can do that as well. Now notice that because we use the Velcro, we can take this off, and then we can get access to whatever we need to do down here, and then we can put it back on again. Now we've got 2 battery packs. We're going to stack those 2 battery packs, and we're going to put them on the back end. You might say, why do we have 2 battery packs? Well, again, you don't have to have 2 battery packs. You can actually get away with just this 1 battery pack that came with the robot. And if you do that, then you will be able to power both the motors, which is to say this board and the motors that are attached to it, as well as the red board on the bottom level of the sandwich here. You can power all of that with just this set of 5 batteries. But here's my experience, is that if the robot is going very fast forward and then you reverse direction very quickly, what happens is you draw too much current from these batteries, and that actually causes the voltage to dip down. And when that voltage dips down, there's a built-in brownout detector in the Arduino, and it causes the Arduino to reset itself. Now that wouldn't be tragic, except for the fact that it also causes you to lose the pairing with the remote control. And in the middle of a competition, you're probably going to lose at least 10 to 15 seconds if that happens. And in my experience, it happened quite a lot. So I decided that I'm going to go with 2 different battery packs. This one is going to provide power to the microcontroller, and this one is going to provide power to the motors. Now, because this one has a case, I'm going to go ahead and put it on the bottom. And so I'm going to go ahead and peel the plastic off of this one. Now, my advice is put this one a little bit to the left. What you want to do is you want to make sure that the switch is accessible, because you want to be able to turn the power on and off. So there we go, I've got that on, and if I want to take it off, it's Velcro, so it can come off. But I like to put it on at the same time there, and then this is going to go up to the front. And then I've got the tape on the bottom of this one. Let me go ahead and peel that off. And then I'm going to put this. Now notice that when I put this on top here, I'm leaving a gap here so that I can get to that switch. So it's going to be it isn't going to look as pretty, but it's going to be very functional. So I've got the wires coming out of the 5-cell, and I've got the wires coming out of the 4-cell. Now the 5-cell is nice. It already has the female connectors that you need to plug into these 2 wires up front. What I did was I routed those wires under, and I just put the Velcro over the wires. So you can see that I've kind of put the wires under here. And then I'm going to go ahead and Velcro it down. That way the power wires can't really get loose. Now, as I mentioned to you in the lab, please don't accidentally get these 2 wires backwards. If you do, then you're probably going to burn up the whole board, and that's going to be a bummer for both of us. So I'm going to make sure, just double checking myself, yep, that's all good. So now I've got this on here. I've got this on here, and it would have worked out a lot better for me if those 2 wires had been the same length. That's something that you can learn from my mistake. And sometimes my experience is that this 5-cell holder is not as reliable as I wished it would be. You see that green light right there? That green light says that power has been connected, but it's a little bit position sensitive. Sometimes I have to take a battery out and put it back in again. You can see the green light's off now. I wish that these were a little bit higher quality, and sometimes it seems like it's the center battery seems to be the problem. Now, the way that this is set up, you'll remember that I've still got these 2 wires left from the 4-cell, but you'll also remember that I've got this jumper right here. And when that jumper is in place, that means take the power from these 2 wires and power both the motor driver and the Arduino on the bottom. Now we're not gonna, you can do that. If that's what you want to do, you can do that. I'm not going to do that. So what I'm going to do is I'm going to take this jumper off. And that says these wires only power the motor controller, and they don't any longer power the Arduino. Here, let me see if I can prove that to you. If I put this back on, and if you look right in there, you see that blue light? That blue light says power is being supplied to the Arduino board, and when I pull this out, that blue light goes off. So now, when I take this out, I'm only powering the motor driver, and I'm not powering the Arduino. Now this thing right here, please don't lose that. Put that right into your plastic box, and at the end, plug that back in again. What we have now is we have these 2 wires, and we need to get power to the Arduino, and we have specially soldered a couple of connections on here for you to do that. Now I'm going to zoom in here so that you can see this a little bit better. You'll see that let me try to find a thing to point with. This one right here says VN, and this one right here says ground. And this, actually there's 2 grounds right next to each other, and then there's a 5-volt. What you want to do is you want to take the wires from the batteries and you want to plug them in to VN. That's exactly what the name says, is VN. You want to plug it in, and then ground. Now when I do that, and I've got to turn the power switch on, but now you'll see that the blue light on the Arduino is on. Now I'm going to flip the battery switch off again, and now I'm going to flip the battery switch on, and you can see that I am in fact powering the Arduino through these 2 wires right here. Now these 2 wires that are next to it, those 2 wires now have a regulated 5 volts available, and that regulated 5 volts is going to be useful to you because you're going to need to wire up a circuit right here. And that circuit needs to be able to do a couple of things. You're going to probably want to have a piezo buzzer so that you can have some music playing. You're going to need to have perhaps an infrared transmitter so that you can ask the launcher to launch a ball. You might want to have an infrared receiver so that you can even tell the system when it's time to kick off. So now, and then I won't do it here, but attach the, well, I will go ahead and do it so that you can see the whole thing. There are, on the front of the robot, there are these two holes right here and here. And the sled has been designed to have holes for these screws that are the right distance apart. Screw one of them in part of the way, and then line up the other one. Now they may not be exactly perfect, so you might need a little bit of wiggling to get them in. But once you get them both a little bit in, then you can go ahead and screw them both all the way in. And once you have done that, the physical part of your robot is complete. And now all that remains is to build this circuit and to write the code. Let's see if I've got everything hooked up here. And then, okay, so you would then be able to pair the controller to the robot, but I'm going to, like a celebrity chef, I'm going to pull out my completed robot here so that you can see that, and then the controller that goes with it. So you can see that I built a little circuit here. I have the buzzer, and I have the infrared transmitter, and I have an infrared receiver. If you want to not run your batteries down, you flip the switch on this one off. Here I'm flipping it back on again, but there's no switch on the other one, so I just take one of the batteries out. And then when you plug the battery back in again, remember, sometimes you got to fiddle with it to get that power to show up. And there we go. So now that's on. And now I can attempt to connect. I call this one TA1, Teaching Assistant 1. Now, I'll show you this in another video for the demonstration, but it's not receiving any inputs here. It will need to have a kickoff circuit. I'll tell you more about the kickoff circuit later. But for right now, let's see, the kickoff circuit. Yeah, okay, we also have an override on the kickoff circuit. You want to choose one button on your controller that will override the kickoff circuit. I chose the square. And so that overrides the kickoff circuit, and now my robot is ready to do whatever it is that I want it to do.